Today's lecture will be bubble sort, but I'd like to close the loop on binary search because I realized we wrote it, we talked about it. I told you how powerful it is, but I didn't really prove the point of how powerful it is, which I'm hoping to do now. So here I'm generating an array of 10 numbers that are sorted, and we can see that here in the console. And then I have a function linear search, which is what Daniel wrote in his mock lecture, which we know is what big O. Well, it's in the name, right? But what do you think, Ketzerin? What is the big O of our linear search, our naive search? Ketzerin?
Yes.
Oh, sorry.
So
What's the big O of the function called linear search?
it's not the log n, it's the. I'm sorry.
Yeah.
Can you
So
repeat?
what's a big O analysis of that, of a function that searches each item in an array one at a time? So our options are, as the array grows, no extra steps or time are required, or extra steps are required but at a constantly increasing rate, or as the array grows, more steps are required at an increasing rate.
This one is like more is like function growth is more is like increase.
Yeah. Yeah. It's going to be an increase, but is it increase at a constant rate, like linear time or quadratic time?
Linear time.
Yeah. So it's big O of n. Yep. And then binary search is big O of what, Ryan?
We learned this yesterday. Is it log n?
Yeah. So as the array grows, the number of steps required increases, decreases, or doesn't change?
Decreases.
No, the number of steps required in time
Oh,
increase,
sorry.
but it
Yeah.
increases. Number of time increases, but at a what kind of rate?
A
Constant.
slower rate.
Yeah, at a decreasing rate. Yeah. That's log of n. Anyway, so two different ways to search for an item in an array. Linear search versus binary search. And now I'm taking linear search with the array of 10 items and looking for -10, which doesn't exist. So it's going to have to check presumably every item. And then I'm using binary search to look for -10, which also doesn't exist. So when I press save on this, we can see linear search takes 0.14 milliseconds and binary search takes 0.14 milliseconds with 10 items. So with 100 items, what do you think, Renata? Are we going to see a change in the time requirement between these two things? It's a total guess, but what do you think?
Sorry, between which two things?
We're comparing linear search and binary search. Right now, with 10 items in our array,
Yeah.
they both take 0.14 milliseconds to find an item. But we're going to
Right.
up that to now 100.
So I say no because, but it's a guess.
Yeah.
It's the same right now. So
What's your guess based on, though? Why do you say no?
Because they're the same right now.
Okay. The same. What's the same right now? Oh, because they're the same on 10. 100 is not that different, so they'll be the same again.
Right.
Yeah, that's good thinking, and that's accurate, right? Well, let's run it again. Oh, okay. They're already. Oh no! See, this is just because of the engines, whatever it's doing behind the scenes. There's really no change between these two again. Yeah. Okay. Let's times it by 10 again. We have 1,000 items in an array. I told you that binary search is so much more efficient, right? It's on its own category. What do you think, David? Will there be a change now, a significant enough change to show up or not?
I don't know if at 1,000, probably not.
Yeah, I don't think it'll show up either. That one did win by almost twice. That one, not much. Oh, no, that one twice again. Binary search. Okay, so already we're seeing a twofold increase in speed. 0.15 versus 0.3, right? So already, if we're Google, and we're doing 1 million of these requests, a second, this could already be monumental. The saving of server time and compute time and whatever. And it only gets better, right? As we get more. So 10,000. So we had a 2x performance increase, binary search. So now 10,000 items in our array. We're getting a 4 times increase of better performance. 100,000 items in our array. What is that? 7 times increase? 1 million items. I don't know. What's 0.1? I don't know. 30 increase? Yeah. So a 30 times increase with 1 million. So imagine if you're Facebook and Google and dealing with these kind of big operations countless times, right? There's so much saved computing going on just from writing a very small functions have such a dramatic impact. So that's why binary search is so cool. Like you can see the performance increase. But binary search is only possible with a sorted array or an unsorted array, Kimberly.
Sorted.
Yeah, so the requirement for binary search is that we have to have a sorted array. Linear search, it doesn't matter. And that's not trivial, right? The question becomes, how do we sort in an array now? Because that's going to take time. So, how do we sort an array? One option is bubble sort. And what do we do in bubble sort? Who can give me... what did you get from the pre-work about bubble sort, Hara? What do we do? Here's an unsorted array. How do we sort it using bubble sort?
So it would look at, the elements to the left and to the right, and then if they're out of order, it will swap them. So the higher number, I guess, would bubble.
Swap if item
if they're not in the intended
is
order.
Higher than right. Yeah. So this is as simple as it gets, right? We start at 42 and we compare 42 and 17. And let me try to put the sorted array below here. There we go. Oops. That's not what I wanted. Okay, so we start at 42. Is 42 greater than 17, Zach?
Yes.
Yeah, so all we do is swap them. 17, 42. And then we go to the next index. And these are swapped now. But so, yeah. So let me, I guess, go down here. So now, is 42 bigger than 88? Jazz?
No.
No. Is 88 bigger than 63, Monica?
yes, they're gonna get swapped.
Yeah. So we swap them. And we keep going like that till we get to the end. But when let me shorten this so we can actually do it and not waste all our time. So is 88 greater than 29? Yes. Swap them. Is 88 greater than 50? Yes. Swap them. Is 88 greater than 5? Yes. Swap them. So we've reached the end of our array. So that means all the items must be sorted, right? Incorrect with bubble sort. We are guaranteed that our highest number made it to the end of the array, but we still don't have a sorted array. So we have to go again. And we might have to go again. But that's the idea of bubble sort. Questions on the overall idea of bubble sort?
I have a question.
Sure.
So I know that with bubble sort, with every pass, the highest number is going to be at the very end. So every time we iterate, it's going to be one less.
Yeah.
So
yes, but that's just a very slight performance increase.
Yeah, I know. Like back in the day, I was very to the details, but then they said it doesn't really move the needle.
Yeah.
In terms of big O.
It doesn't
really matter.
It almost does nothing, right? It's just, but it is, I guess, why not? If you can save even a millisecond, why not do it, right? I wasn't even going to show you guys that tweak because it's so minor, but we can if you want. Anyway, let's work on implementing bubble sort. So we take in an unsorted array, and that's it. We don't even need a target, right? Because the goal is, so like I'm always telling you guys, let's list our input and our output. So here we have an input, possible input, and our possible output is what? 5, 17, 29, 42, 50, 63, 88. Yeah. And then the real nerdy question is, well, what algorithm did my brain use to do that just now? I don't know. That's a question, I guess, for later on. But anyway, we're going to do bubble sort today. So we take in unsorted array and we do, our output is hopefully a sorted array. So we're going to do exactly what we did visually here. We're going to first iterate through the array. So how can I iterate through my input array? Ronald.
We could just create a for loop. So for let I set it to 0 as long as I is less than array.length I++.
Yep.
Yeah.
And let me do some sanity checks. Let me actually invoke this function, just like I'm telling you guys when you're working on these technical interviews, you should be doing right away. Just make sure it's all nice. Also, I noticed how you guys, when you're doing these mock technicals, you never press save and have prettier, check it and format it. You should kind of be doing that, just the same way you code, right? No, already here I'm getting an error, so that's good. So I know I have to pass in an array. Yep. Okay, that looks good. So we said if the current value of the array at the index is greater than the value of the array at the index +1, swap them. How can I write that in code? Daniel, are you there?
Yeah, sorry, it was plugging my laptop. I'm sorry, can you repeat that?
Yeah. So if the current value of the array, so this would be like array bracket I, what we're currently on, if that's greater than the array at index plus 1, the value of the array at index plus 1, we want to swap them.
So it would be an if statement.
Yep.
Probably. So if r at index I is greater than r at index I plus 1.
Yeah. And then we want to swap. So this is probably the trickiest part, but do you have a guess? Yeah.
Would we need to initiate a new array somewhere, like at the top, and maybe?
Well, that's a great question. If you were getting this on an interview, do you care that this is mutating or not? I'm gonna say let's make a mutating function.
So I guess let's declare a new array at the.
No, that's the opposite.
Oh.
Yeah.
Oh, sorry, my bad.
Non-mutating would be declaring a new
non-mutating.
array. Yeah.
Okay.
Mutating, we're changing the input itself.
Okay. Yeah, I'm not sure then how to.
Yeah, this is the trickiest part. Alex, any guess? How do we swap two items in an array? We can even take this outside of this function. We could just do it here. Const temp equals. How can I swap 17 and 42 in our temp array?
Do you need another for loop for the?
No. Yeah, no. Don't need another for loop. How can I swap 17 and 42 just using some JavaScript?
Is there a way to like push, or is there a way to like make index of 42 to? Never mind. I thought I had something, but I'm not in the right track.
Victor, you have a guess?
Temp array equal
Temp array equal?
or index I.
For now, forget all this code exists. We just have this array called temp array. So we don't have anything called R, and we're trying to switch 17 and 42. So the only code that exists is line 50. Hara?
Equals 17.
Temp array equals 17?
Oh, you want to switch? Sorry, I forgot which one you said you wanted to switch.
Sorry, I want to switch 17 and 42. So right now 17 is at index 0 and 42 is at 1. Let's make this 170 42. Then it makes sense in our scenario. So 170 is bigger than 42, so I just want to switch them.
Well, temp array at index 0.
There we go. Yeah. Temp array at index 0 equals
temp array at index 1.
Very nice. Yeah. Now when we console.log temp array, we have the 42 is happily swapped into index 0. But now we wanted the 170 to be at index 1. But what problem are we facing?
Would you have to store the value of index 1 somewhere and then make it? Because when you run that line 51, you're basically overriding the first.
Yeah.
one.
So we want a temp of what?
Which one did we end up? Oh yes, temp. So temp index 0.
Mm-hmm. Okay, so now we want temp array 1 to be equal to what?
Temp.
Yeah, and the naming of these wasn't great. How I called this temp array. It's a little confusing. But anyway, so this is how we swap two items in an array. So it's going to be this same type of logic, but we now have to do it here. So maybe I should even copy this, right? So how can I modify this logic to make sense for our function? So instead of temp equals temp array bracket 0, what should temp equal?
Number, maybe?
I.
Array I.
There we go. Yeah,
Index
it's
I.
a team effort. Array I. And this line should be modified how?
Array of I.
Yeah. Array of I. So that's like on the first iteration, this would be array bracket 0 should equal what?
Array of I plus 1.
Yeah. And then array of I plus 1 should equal what? 10. Yeah, we already... Oh, yeah. We already have it. Yeah. And let's make sure this makes sense. So when I console.log, what do I expect to see at this point in our code? Roman, are you there? What will I see in the console right now?
Would it be sorted?
Not completely. Or is this array already sorted? No. So is 17 bigger than 42, Roman?
No.
Is 42 bigger than 63?
No.
Is 63 bigger than 29?
Yes.
Yeah. So the 29 and the 63 will swap. Is the 63 bigger than 50?
Yes.
Yeah. So then the 50 and 63 will swap. And so on and so on. Let's see if that happened. So we got 17, 42, 29. So I think this worked, but it needs another iteration, right? Just like we were talking about before. When you get, on the first iteration, you get the highest number over, but that doesn't mean the array is completely sorted. So the thing is, I want this same logic to run again if it's not sorted. So I'm going to throw this in a while loop so it just keeps on running. But how do I make this not infinite? What would be the break condition?
If nothing is sorted
If nothing is sorted.
on that iteration, so you want a flag variable.
Yeah. So did we swap or something? So let did we swap equal false initially. Well, actually,
Well, you just do a for loop and compare each pair.
Yeah, let's come back to that. Let's finish the loop on this. So we have a did we swap equals false, but if we're in this block, what does that mean about did we swap?
You would have to put, like, did we swap equals true?
Yeah, did we swap it now equals true. And if and now if did we swap is still false, that means we didn't make a swap that whole iteration. That means we can return the array, right? I'm definitely not doing this by memory, as I hope you can tell, which is fun, right? You get something new every time.
Is line 41 going to work inside of a while loop?
Yeah, why not? We're just declaring a variable.
Oh, you can declare it over and over?
Yeah, it shouldn't matter. So did we swap equals false? If it ends up swapping, it becomes true. This doesn't hit. The while loop goes again. Did we swap equals false? Oh, wait, no, I'm sorry. So did we swap equals false? It becomes true. Yeah. So this doesn't run because this is true. And then it just goes again until it doesn't swap, I think. And then we have a sorted array. But now the hard question is, what is the big O analysis of this? And for big O, we always consider what is the worst case. So what do we think the worst case is for this?
Quadratic?
Yeah, quadratic. So the worst case is that for every item, we have to check every other item. So we have an n squared situation. It's kind of hard to see though with this while loop. Or it's possible. What's our best case scenario?
Everything's already sorted.
Yes, but I'm sorry. What's our best case scenario with the big O? Linear.
Oh, man.
Yeah, we still have to go through it all once just to know. Okay, we made very, very good time, which is fine because you guys will have more time on your project. But any questions on bubble sort? Bubble sort is going to be the easiest of all the sorting algorithms, in my opinion. Almost all the other ones require recursion, which I don't know about you guys, but my brain just shuts off when I see it. I have to draw things like like a weirdo. I literally have to draw the functions. So any questions on this one? Bubble sort.
Yeah, I had a question, Max. So I know like the temp swap variable thing took me a long time back in the days, but I think there's another way to swap variables, right? In JavaScript, the new modern way with array destructuring.
Swap, JavaScript, array, items. Not that I use enough to
Basically,
remember.
you can just wrap both sides on arrays and then just put array of I, comma, array of 1, and then flip it on the other side. So it'll be like array of.
Okay, let's try this. So array I plus 1 equals array I plus 1 array I. Okay, let's run this again and see if this crazy syntax works. And yeah.
I don't know if it's easier or not, but if anybody.
It's certainly not easier to my eyes, but if it's easier to your eyes, use it. I'm not
just
there.
the inverse.
Maybe 10 more years, and I'll that'll mean something to me. Yeah. Any other questions? Okay. Let's get into the breakout rooms.